Okay, so now that we can write chemical formulas and balance chemical equations, it's time to look at some actual specific types of reactions. And when we do so, we're going to be applying these skills that we've just learned those to the different types of reactions we have. So essentially every type of reaction we do, we're going to need to be able to write the chemical formulas for the substances we're using and balance the chemical equations. So we are going to begin with our different types of reactions with decomposition reactions. So the learning objective for this lesson is to determine the products of decomposition reactions. So very simply, a decomposition reaction is when a simple compound is broken down or decomposes to form two or more products. Now the products can either be elements or they can be other compounds. Now we're going to look at this idea of a general decomposition reaction. Now these general decomposition reactions you do need to remember, and once you've memorized them, you can then apply it to any different situation. So carbonates. Whenever we have a metal carbonate, it will always break down or decompose into a metal oxide and carbon dioxide every time. So here's our first example, sodium carbonate. Sodium carbonate is going to break down into sodium oxide and carbon dioxide. Really neat, nice and easy, right? And now, like I said, because we know how to write these, we should be able to write this as Na2CO3 gives us Na2O plus CO2. And we should be able to balance this equation. If you look very carefully, you'll notice that it is already balanced for us. There's no actual need to do anything further with it. When we look at oxides now, they have a general formula that tells us metal oxides will give us a metal plus an oxygen. So an example will be magnesium oxide. It's obviously going to break down into magnesium and oxygen. Very simple. We write that as MgO plus Mg plus O2. And if we have a look, you might notice now that it's not balanced. So I'm going to quickly balance that by putting a 2 at the front of the magnesium oxide and a 2 at front of the magnesium. Now that one is balanced. Let's now jump straight into the experimental side of this. We're going to look at the decomposition of copper carbonate, one of my favourite experiments just because it looks cool. So in order to decompose copper carbonate, we need to add energy, and we're going to do that in the form of heat. Normally we would use a Bunsen burner. I'm going to improvise. So our product, based on our general formula, should be carbon dioxide. So to test for carbon dioxide, what we're going to do is called the lime water test. So what we have in here is lime water, which is actually calcium hydroxide. And just to prove that this does work, I'm going to blow some of my air into here, and as we all know, we breathe out carbon dioxide. So this clear water that you can see, this lime water will turn cloudy when I blow some carbon dioxide into it. All right, you can see it's gone all cloudy there. So that is how we'll know if carbon dioxide is being produced, if our lime water turns cloudy. So as we mentioned, in order to initiate this decomposition of copper carbonate, we need to add some energy. We're going to do that in the form of a Bunsen burner. Getting this Bunsen burner ready. Funny, this Bunsen burner smells like sausages. Okay. So, what we've got is the copper carbonate inside a test tube which is closed with a stopper, so that any gas that's produced will go down the tube and into our lime water. You can see over here there's some bubbles being produced. Okay, so what we can see clearly here is that the lime water here, which was originally clear, has now gone very cloudy, indicating that the gas being produced is carbon dioxide. So the results of that experiment clearly show us that when we ran that gas that was produced through lime water, it turned it cloudy, and that indicates the product was carbon dioxide. So our word formula and a chemical formula is what I'd like you guys to have a go at doing now. So we had, well, you know what they were. I said them a couple of times, so I want you to write them out. and then I want you to write a chemical formula and make sure that it is correct and balanced. So pause it now and have a go at that yourself, and then I'll show you the result. So you should have got copper carbonate plus copper oxide gives us carbon dioxide. And our chemical formula will be CuCO3 plus CuO plus CO2. Now we're going to look at another quick experiment, the decomposition of hydrogen peroxide. Now this one doesn't follow the rule for general oxides. In order to decompose H2O2, we need to add a catalyst. So what the catalyst means is we're going to put it into the equation. We're not actually going to put it in the equation. We're putting it into the mix, but it's not actually going to be part of our equation as such in terms of that balancing nature. So the gas product should be oxygen, and we're going to test this by adding a glowing splint. Okay, I've got the hydrogen peroxide ready, and I'm going to add in the magnesium dioxide catalyst. Just going to get that decomposition starting a lot faster. Now I'm going to cover it up to capture the gas produced. Now, to confirm that this is oxygen, I'm going to add a glowing splint and if it reignites, there you go. It reignited, tells me that there was oxygen in there, oxygen being a very flammable gas. So the results of that experiment showed us that the gas produced reignited a glowing splint, indicating that it was in fact oxygen. So once again, I'm going to get you guys to have a go at the word formula. In fact, have a go. Pause it now and have a go. And what you should find is that you've got hydrogen peroxide, gives you water and oxygen. Now you'll notice what I've done here is I've included the magnesium dioxide and I've just put it above the arrow, and that's where we would put that catalyst. Now, chemical equation. I want you to have a go at doing the chemical formula here and making sure that that one is balanced as well. And of course, you would have got hydrogen peroxide gives you H2O plus O2, but it does need to be balanced. And we need to put a 2 at front of the water and the hydrogen peroxide. So, just to reiterate, decomposition reactions break down molecules into smaller molecules, and they follow those generic formulas for oxides and carbonates. And they're all that we need to know moving forward in Year 10. So make sure you remember those general formulas and how to apply them to different scenarios.